Today's work focuses on measuring angles, and the tool that we use to measure angles is called a protractor. So this is a protractor, and I'm doubtful that you probably have protractors laying around your house, but maybe you do. And if you do, great. We can definitely use those to practice measuring angles. But if you don't worry, because the workbook pages we're going to be doing don't require you to have a protractor. So I do want you to learn how to use them, and hopefully we'll be back together soon, and I have a whole class set that we can use. But a few things I want you to note about a protractor. First, an important line we need to know about is the center point. Okay, so here's the center point. This is where we're going to line up the vertex of an angle. That's where the two rays meet. So this is where the vertex will touch when we're measuring an angle, is the center point. Then we have what's called the baseline, and this line is the baseline, and we're going to want the ray to be lined up. If this is the vertex, then the ray of the angle will be lined up with this baseline, and I'll show you that in just a minute. And then the other thing to note about the protractor is that it has an inner scale. You'll notice it on the inside here, and it also has an outer scale. And you need to make sure you're using the right scale when measuring angles, and I'm going to show you how to know which scale to use in just a minute. Okay, let's look at this first angle, angle BAC, or we could call it angle CAB. We're going to measure this using a protractor, and they have the image over here, but I want to show you how you would physically put the protractor over the angle to measure. So remember, we have that center point, and we want to put that center point right on the vertex. And then it's important, so let's say we get it lined up there. It's important that we get this ray AB, lined up with that baseline. So you might have to kind of turn it a little bit until you get it lined up perfectly with the vertex at that center point and the ray lined up perfectly on the baseline. Okay, so it shows you that in this image over here too, but I wanted you to see how you would physically do that with a protractor. So now that we have it placed there, we have to decide, are we going to use the inner scale or the outer scale? Well, our little friend down here is giving us this tip. He says, since AB, that ray AB, passes through the 0 mark on the outer scale, we use the outer scale to measure this ray. Let me say that again. Because ray AB passes through 0 on the outer scale, we know we're going to use the outer scale to measure this angle. And so if we look at this, it looks like it falls directly between 40 and 50. And so we know that that angle measure would be 45 degrees, as it says right down here, 45 degrees. We can also ask ourselves, what kind of angle is this? Remember, we went over, or if you watched the video about the angle measures, there's right angles, acute angles, and obtuse angles, and this definitely is a cute little angle. So we know it's going to be less than 90 degrees. So that confirms that 45 degrees would make sense. If we by mistake used the inner scale and said, oh, it's 135 degrees, we'd have to stop and say, wait, that doesn't really make sense, because this is an acute angle. I know it has to be less than 90 degrees. An obtuse angle would be greater than 90 degrees. You can also just use your common math sense as well. Let's look at this next angle. This is angle DEF. And you can see this was the starting point, and the arrow is showing which way the angle was opened up. And so if we were to measure angle DEF, the vertex is at the center point, and ray EF is lined up along the baseline, and we can see that EF passes through 0 first on the inner scale, and so that tells us we're going to use the inner scale to measure this angle. So if we look, the ray ED goes through 70, and so this angle measure would be 70 degrees. Let's look at angle LKJ. You can see they already have it lined up so that the vertex K is at the center point, and that ray KL is lined up along the baseline. And we look to see, okay, ray KL passes through 0 on the outer scale. So we're going to use the outer scale to measure this angle. So we're going to run our finger along the outer scale until we reach ray KJ. And we can see that it's between 100 and 120. Gosh, that's hard to read on this picture, isn't it? So it looks like it lands right on 110. It's covering that 1 on 110. So 110 degrees. Then you can stop to ask yourself, now does that make sense with this angle? I know that an angle greater than 90 degrees is called an obtuse angle. This angle is definitely greater than 90 degrees. It has a big, wide open mouth. And so it is an obtuse angle, right? If you watch the video on our different types of angles. And so 110 degrees would make sense for this angle measure. Okay, now again, I know you probably don't have protractors at home, but I do want you to see how you have to kind of maneuver and kind of make or line it all up in order to measure these angles. So let's start here. If we put our protractor on the vertex, B is our vertex on this angle, and then we kind of move it to line up ray, is it BC? Yeah, ray BC along the baseline. Then we could ask ourselves, let me grab my pointer tool here. Okay, ray BC passes through 0 on the inner scale, so we're going to use the inner scale, and it is right at 90 degrees. Now a 90-degree angle is kind of interesting because you can actually use either the inner or the outer scale. You're going to end up with the right angle measure. So this is actually a 90-degree angle. Okay, well, it doesn't look much like a 90. Let's look at this next one. Okay, if I line up the center point with the vertex F, and then I gotta get it nice and lined up, and then I line up the baseline with ray FG. Okay, I look to see which line or what does FG pass through 0 on the inner scale or the outer scale? It passes through 0 on the inner scale, so I'm going to use the inner scale, walk my fingers up, and see that this angle is about 80 degrees. And it makes sense because it almost looks like a 90-degree angle, right? So this is an acute angle. It's less than 90 degrees, and it's about 80 degrees. Now this one, if we line up the protractor with the center point here, and I line my, oh goodness, there we go. We line ray YZ up with the baseline. That's about perfect. Okay, then if I grab my pointer tool and I see, okay, ray YZ, does it pass through 0 on the inner scale or the outer scale? It's the outer scale. So I know I'm going to use my outer scale to measure, and this is almost at 100 degrees. So this angle would be 100 degrees. And I can also use my common sense and say, okay, is this angle greater than 90 degrees? Yeah, just barely, just barely. So 100-degree angle measure does make sense for this angle. Okay, last one. The angle is, or the center point is lined up, oops, with, let's see here. Come on, here we go. The center point is lined up with the vertex. The baseline is lined up with ray LK, and LK passes through 0 on the inner scale. So I know I'm going to use the inner scale, and my pointer got stuck. So I'm just going to have to visually watch me walking my fingers up on the inner scale to about 130 degrees. 130 degrees. I ask myself, does that make sense? Is this angle greater than 90 degrees? Yes, it's got a big, wide open mouth, so that angle measurement does make sense. It's an obtuse angle.